A 12-volt battery of 0.05 ohm resistance and another battery of 12 volts and 0.075 ohm resistance supply power to a 2 ohm resistor. What is the current through the load? So let's go ahead and draw our circuit first. So from our problem, this is just one component, as well as this is also one component, and both of them are supplying a load, a resistor of 2 ohms. So now let's also label the polarities of each component. For this resistance, since the current is flowing in this direction and leaving on this side, so this should be negative, and this should be positive, as well as here. And for the resistor, since the current is flowing in a downward direction and leaving on this side, so this should be negative and positive. Next is to write our equations, and since we have 3 unknowns, therefore we'll need to find 3 equations as well. So for KCL, remember that the current flowing in is positive and the current flowing out is negative. So looking at this node here, okay, so let's label them first: A, B, C, D, E, F. So for the node B, the current flowing in are I2 and I1. So that's I1, I2, and the current flowing out is IL. So we're gonna write it as I1 plus I2 minus IL equal to 0. So this is now our first equation. Next, for KVL, just a gentle reminder that the sign convention we'll follow will be the sign of the component we'll be leaving at. So for example, if we're going in this direction and we're leaving on this side, the convention we'll write will be negative IR. Otherwise, this direction, we're leaving on the positive side, so we're gonna write it as positive IR. Okay, so for loop DABCD, we'll go in this direction. So that's positive 12 minus IR, or 0.05 I1. Next, negative 2 IL equal to 0. So this is now our second equation. Next, for loop FCBEF, so we'll go in this direction. Alright, so since we are leaving on the negative side, we'll write it as negative 12. For here, since we're leaving on the positive side, so that's plus 2IL. And lastly, since we're leaving on the positive side, that's positive 0.05 I2 equal to 0. And so there we go. We already have 3 equations. And so at this moment, we can go ahead and look for our missing variables. We can use different methods on how to do that, but the fastest way for me is to use the calculator using the equation mode. So you can use it as well. I can teach you on how to do that. So we're just going to rearrange our equations here. Okay, so right now we can go ahead and input this to our calculator. Okay, so just choose mode and then look for 3 unknowns since we have 3 unknown variables. Okay, so let me go ahead and rewrite the unknown variables here. Okay. Alright, so these are now all the values that we're going to enter on the calculator. So once you hit the equal sign, it will give you all of the answers for each of these unknown variables. So the first one that will appear would be the I1, next is I2, and lastly would be IL, which we're looking for from the problem. Okay. Okay, so the first one is 3.547. This is amps. Next is 2.365. And lastly is 5.91 amps. Okay, so from the problem, we are asked to look for the current of the load. So therefore that is IL. So this is our answer, 5.911 amps. So from the choices, we will choose letter D for our answer.